There is a version of Thais that people still carry in their heads, like a place that exists just slightly out of reach. As if they could turn a corner and find it again if they walked far enough. In that version, mornings begin quietly, with the hum of life moving at normal pace. And water, something so simple and so ordinary, flows without thought. You just wake up and you go to your bathroom and you just want to turn on water. But you turn it on and nothing comes out. And maybe that's the cruelest part. Like, people of Thais actually thought that maybe something so valuable, so simple like air, would not be taken away from. But one day it was just gone. At first, it didn't feel like a disaster. It just felt like a delay. But then hours go by and the pipes literally remain silent. And by the end of the day, something subtle begins to settle into the air. It's not panic yet, but a kind of unease that just doesn't have a name. And then the next morning, people try again. Nothing happens. And this is the moment where the city begins to understand that something deeper is going on. Maybe tomorrow, someone says. Maybe tomorrow there will be water. But when they say it, they don't really believe it. But then tomorrow comes. Nothing. So Thais is a city that once functioned on fragile but working infrastructure begins to fall backward in time. Not all at once, but steadily. And when modern systems disappear, people reach for something older, something more basic, something that existed long before pipes and electricity. They turn to wells. If you strip away everything modern, pipes, pumps, grids, infrastructure, and reduce survival in the desert to its most essential form, you end up with a single question. How do you reach water that you cannot see? The question is what created the well, and in Arabic desert communities it was never just a hole in the ground, it was engineering, memory and strategy. A traditional well begins with knowledge, not tools. Before anything is dug, someone has to know where to dig. In many Arabic communities, especially among Bedouin groups, this knowledge was built over generations. Subtle signs matter: the type of vegetation, the behavior of animals, even the temperature of the ground at dawn. These were clues pointing to underground aquifers, the hidden reservoirs of water trapped in layers of rock and sediment. Digging in the wrong place could mean weeks of wasted labor and death by dehydration. Digging in the right place, however, could sustain a community for decades. Once a location is chosen, the process is brutally physical. Workers dig vertically, often by hand, sometimes lowering one person at a time into a narrowing shaft. The deeper they go, the more dangerous it becomes. Walls can collapse, but when the water is finally reached, it seeps slowly at first. That's actually an important detail, because a well doesn't always produce water like a faucet. It fills gradually, and sometimes taking hours to recover after each use. But this recovery rate is what defines how many people and animals a well can sustain. To prevent collapse, wells are lined with stone brick and later concrete. This lining isn't just structural. It also protects water quality by limiting contamination from surrounding soil. Above ground, the well often becomes a focal point of life, a place where ropes, buckets, and later pumps are used to draw water. In deeper modern wells, diesel or electric pumps pull water from hundreds of meters below, tapping into fossil aquifers that may never refill within a human lifetime. Across parts of the Arabian Peninsula and the broader Middle East, communities developed Qanat systems, or Falash in Oman, underground channels that gently slope from an aquifer to the surface, allowing water to follow naturally without bumping. So these systems required precision. Too steep, the tunnel might collapse. Too shallow, and the water just doesn't flow. They could stretch for kilometers, with vertical access shafts spaced along the route like a chain of hidden wells. Maintaining them was a communal effort, governed by strict rules about who could use how much water and when. A well is only sustainable if people cooperate, how quickly it refills, how much can be drawn without exhausting it, and animals were watered in sequence. Crops were irrigated according to rotating schedules. Violating these rules wasn't just selfish, it actually threatened the survival of everyone.
مایه زندگی ما با ید و نسل ما بوده وظیفه اینه که تا نفس آخر حمایت کنیم از قنات.
There is a well on the edge of a neighborhood in Thais. It used to serve maybe a few dozen families, now it serves hundreds. Someone brings a bomb, and that changes everything. So someone says, we need it. We need it. We need that pump. The pocket was too slow. It allows faster extraction, more efficient use of time, but it also breaks the balance. Because the well's recharge rate hasn't changed, it still fills slowly. Now water is being pulled out faster than it can replenish. Well, obviously the well just doesn't fail immediately. It has time to replenish. Instead, it weakens. Water levels drop slightly, then more. The pump has to work harder. Eventually it starts pulling up sediment along with water, a sign that the aquifer is being stressed. And suddenly the well is no longer just a shared resource, it's contested. In some cases across Yemen, this kind of tension has escalated. Wells have been sabotaged, restricted by local groups trying to control distribution. Because controlling a well means controlling time. How long someone can stay in their home, and how long they can maintain hygiene, how long their children can avoid disease.
At the same time, the Saudi-imposed blockade on the country has prevented the entry of fuel. Water pumps have stopped working. The main pumping station for water in Qanat is currently operating only 60 out of the 330 wells due to the blockade.
Humanitarian organizations step in with what is essentially a temporary lifeline, water trucking. So tankers bring water from wherever it can still be extracted and deliver it to neighborhoods that have none. The second approach has been repairing and maintaining existing infrastructure wherever possible. In parts of Yemen, aid groups and local engineers have tried to restore damaged pipelines, fix pumping stations, and reconnect neighborhoods to centralized water systems. When this works, it's transformative. But here's the problem. Infrastructure depends on stability. You can repair a pipe, but if electricity is unreliable or fighting resumes nearby, the system fails again. One of the most important developments has been solar-powered pumps. Instead of relying on diesel fuels, which is expensive, scarce, and often controlled, during conflicts, solar panels can power pumps directly. This has been a major shift in rural Yemen and around Taiz. Wells that were previously unsuitable due to fuel shortages can suddenly operate again. But there are still hidden complications. This might sound a little quirky. When it's easier to pull up water, you also make it easier to take too much. So solar pumps don't solve the underlying problem of limited groundwater, they just make extraction cheaper and more consistent. And without strong regulation, which is extremely difficult during conflict, this can accelerate depletion. Another major effort, community-level water management. So in some areas, local groups try to reintroduce structured sharing systems, allocating time slots for water use, limiting how much can be drawn, and organizing maintenance of wells. So, in conclusion, the core problem is unsustainable groundwater depletion, and war makes it impossible to control it. So people keep extracting more water than the aquifers can replace just to survive, and until that cycle is slowed or stopped, nothing else, no repair or technology can really truly fix that.